This is the second half of the lecture for Chapter 2, the Relational Model 1, Introduction, QBE, and Relational Algebra for CIS 307. So we're ready now to work on example 16. So this is on page 55 of your textbook. They are looking for the zip code for the customer located in the city of Fillmore is incorrect. It should be 33363. We're going to change the zip code value of these customers to the correct value. Rather than opening the table to edit the data, we're going to use what's called an update query. An update query allows you first to find records that meet certain criteria and then to change something in the records that meet that criteria. So we start off and actually just create a select query like we would with any other query. So in Access, we're going to click Create and Query Design. And for this one, we need the customer table. And the first goal is to find the customers with that zip code. So I want the city of Fillmore. And then I want to also see the zip code. And when I view the records, then I can see, in this case, there's only two. Now, there's such a small amount of data in our data sets, but keep in mind there might be 200 of these. So when you see two of them, you're thinking, well, I could edit it manually faster, and you probably could, but we need to use our imagination and imagine that there's hundreds of them. So up here across the Query Tools Design ribbon, you can see we've been working on it as a select query, and we want to move across here and change it to an update query. When we click Update, we get an additional row added to our query grid, this Update To row, and what we want to change is the zip code, and we want it to be 33363. Now, previously I've just been hitting the View icon to toggle between the design and the data view. But if I'm doing any of these other queries, make table, append, update, crosstab, delete, any of these other types of queries, then I need to hit the run in order to actually execute the query. You could have used run all along. I keep run separated for those action queries, and I use the toggle on the view for all of my select queries. Action queries are a little more dangerous because you can't undo them. You'd have to actually, for example, if I updated the wrong thing, I would have to reverse it in order to update it reverse it back. I'd have to run another update query. In real life, if you're ever going to run any of these update, append, delete, make table queries, you want to make sure that you do have a complete backup of your data prior to running these types of queries so that you can reverse it back in a much quicker fashion. So I'm going to go ahead and click the run, and it's going to come back immediately and tell me that I'm about to update two rows. Once I click yes, then I have updated those rows. Now I personally always switch back to a select query, so that now again I'm selecting those with Fillmore, and you can see that the zip code did change to 33363. So the update query did work. A query like this has no purpose to be run again, so normally I would not save this type of a query, but for purposes of class I need to save the query so that, when you do your examples, so that the instructor can actually see that you did write the query in the correct fashion. Example 17 is another type of action query. It starts on page 56, and this is a delete query. First it talks about what a delete query is on the bottom of page 55. But basically a delete query is going to, similar to an update query, it's going to begin by finding all the records that meet certain criteria, but the action that's going to take place in this case is it's going to actually delete all of those records that meet that criteria. Again, I do usually run it as a select query first. So I'm going to go into my query design, and this one is off of the order line table. And I am looking for all the lines where the order number is 21610 as my criteria. So I'm going to toggle over, and I'm going to see that there are two records. And in real life I might even go ahead and select all the other fields as a verification so I can see compare it to my paperwork, because delete queries are so dangerous. Again, always make sure you have a complete backup of that table prior to doing the delete query, so that if you did screw it up, you can go back to what it looked like previously. So I'm going to go ahead and go back to the view, and for our purposes, I really don't have any need to see those. So I'm going to change this right here from a select to a delete query. So again, my query grid down in the bottom has changed, and I have this additional row of delete, and it says where. And that is a drop down, and there's another choice there where I could delete from something. We're not going to cover that here. They're only worried about the where in this text. So basically I'm saying from the order line table, everything where the order number is 21610, I'm not just deleting that field, I'm deleting the entire record. I run, and it says you're about to delete 2 rows. Once you click yes, you cannot undo it. Are you sure you want to do this? And yes, I do. Again, in real life, this is not a query I would really usually have a reason to save. Once that record's been deleted, or those records are deleted, why would I ever need to do it again? But for purposes of class, we are going to need to save all of the queries that were assigned, and that was example 17. Example 18 is using one more of the action queries. This one is using a make table query. A make table query is taking records that meet usually that meet criteria. Sometimes you're doing it in order to take data out of creating a query that shows records from multiple tables, changing that view, what I actually see. I may use a make table and place it in another table. So then in real life, the reason I might do this is to export it out for somebody to have the data in Excel or something like that. So I'm going to create a new table containing the customer number and customer name, and the number, first name, and last name of the customer sales rep. And I'm going to go ahead and name it table customer rep. So back in Access, and to begin, I need to go to my query design, and I need both the customer and the rep table. This query has no criteria. It's just taking fields from both tables, which are already connected through that relationship. From the customer table, I want the customer number and customer name. And from the rep table, I want the rep name, the first name, and the last name. I'm going to go ahead and take a look at my data, and just that confirms to me that I am going to put the correct data into my new table. So I always take that moment to take a look at the data. And then in my query type, I want the action query of make table. Now with this one, once I push the icon, it will pop up and ask me what I want this new table to be named. I'm going to name it TBL customer rep. And it also gives me the option to have this table be in the current database, or to actually create it in another database. For our purposes, we want it in the current database, so I simply click OK. Now that does not create the table. The table is created when I actually click the run icon. Tell me you're about to paste 10 rows into a new table. Are you sure? Yes, I'm sure. This one is nowhere near as dangerous as an update or a delete query, simply because if I now realized, whoops, wrong stuff, I could go back and just delete that table I created and correct it to what I really wanted. I'm going to go ahead and save this query as example 18. And I am going to I'm just going to ignore that for the moment. I'd have to research it. I must not have something set up. But I'm going to go ahead and take a look at my table customer rep, and you can see that is a table now, and that data has been, basically it's like taking that data and exporting it out into another table. And I did change the layout, so when I save, it'll ask if I want to save the layout of the customer rep table, and that's because I did widen that column. And that concludes the examples that are done in this chapter in using Access. The remainder of the chapter discusses relational algebra. And relational algebra is kind of prepping you for what's to come in the next chapter when we begin to look at the structured query language, or SQL. So first, their author is suggesting that we get an understanding of relational algebra, which is a theoretical way of manipulating a relational database. It includes operations that act on the existing table, sort, produce new tables, and similar to the way the operations of addition and subtraction act on numbers to produce new numbers. Each command ends with the giving clause followed by a table name. This clause represents that the result of the command is going to be placed into a temporary table with the specified name. This hopefully will make sense once we start to do a couple of these. So they start off and talk about the relational algebra action of select. The select command takes a horizontal subset of a table and always includes the word where followed by some type of a condition. So example 19 on page 59 says simply to list all the information about customer 282 from the customer table. Using relational algebra, this is just a select query. So I'm starting off with the word select and then the table that I'm pulling the data from. Remember, a select is simply pulling an entire row. A select always has a where. So I'm selecting a row from this table where the customer number is 282. Giving means create a new table with this data, and the table that we're going to create we're simply calling table answer. So in relational algebra, this is saying select all the rows from table customer where the customer number is 282. And whatever those rows do, put them in a temporary table called table answer. I'd put them into that temporary table so that I could use that data in my next action. Now, temporary table aspects should make more sense when we enter into the SQL chapter. Example 20 is another example of using the select action from relational algebra. Here the task is to list all information about customers with credit limits of $7,500. So again, I'm starting with select. Whenever there's a select, there must be a where. So you know that's it. Those two go hand in hand. This is a select is always a row. So this is the table that I want a row of. So I'm saying select a row of this table where the credit limit equals 7,500. All of the rows in this table where the credit limit is 7,500 are going to be stored in a temporary table, again called table answer. The next one that they talk about is a command called project. The project command takes a vertical subset of a table. If you think about it, a select command takes a row, a project command is taking a column. In the same way that select always includes where, project always includes over, followed by a list of columns to be included. The first example they give you is on page 60. They want us to list the number and name of all customers. So the customer table has numerous fields in it. So if we did select, we would need some type of a where. Well, we don't have any condition. We want all of the customers, but we only want two of the columns. So what we're saying here, remember, project always has an over. So we start with project, and then where do we want to get the data from? From table customer. Which columns do we want? The customer number and the customer name. So it's taking only these two columns out of that table and storing them again in that temporary table called table answer. So project means select out of this table these two columns and put them into this temporary table. Another example on page 22, example 22 on page 60 says list the number and name of all customers with credit limits of $7,500. So in this case we have a criteria, but we also only want certain columns. This example means that we first have to do a select and then we have to do a project. So select always has a where. So we're selecting from this table where the credit limit is this. Select is always a row, so I now have the entire rows of every record in this table where the credit limit is 7,500, and I'm storing it into this temporary table right here. Then I'm using that temporary table in my next query, in my next line. So now I'm saying project from this temporary table over, remember a project always has an over, and the fields I want are the customer number and the customer name. So first I've narrowed down the rows that I want in the select here, and then I'm narrowing down the columns in the project. Select from table customer all the records where the credit limit is 7,500. Put it into a temporary table called temp. Then select from that temporary table those columns, customer number and customer name, and put those in a temporary table called answer. The next command they discuss in relational algebra is the join command on chapter 2. Or excuse me, on page 60. The join command allows me to extract data from more than one table. It combines the data based on values in the matching columns. In other words, it creates a new table where the rows in this table are a combination of the rows from the join tables, a concatenation of the data. The matching column is referred to as the join column. And we've talked about this some when we've talked about relationships, that you have to have the fields, the primary key go to the foreign key. You have to be able to create the relationships, and that's what join is doing here, though in relational algebra it's referred to as the join column. So the example 23 on page 62 starts off very simply. For every customer, list the customer number, customer name, sales rep number, and sales rep's last name. A join command is always going to have a where. So what I'm doing is I'm saying join these two tables right here, and I could list other tables if I needed to and be a little more complicated, but I'm joining the customer and the rep table where the rep number equals the rep number. Well, that field name is the same, and it doesn't know which one I'm referring to. I'll get an ambiguity error. So I have to tell it which the table name, and I use a dot to separate the table name from the field name. Again, on the other side, I have the table name, and again I use a dot to separate the table name from the field name. So when I look at this as a whole, I'm saying join these two tables together where these rep numbers are the same, and take that data, that resulting data set, and put it into a table temp. Now all these three commands do is actually join the two tables together. Then I go on and I use my project command in order to select only those columns that I want. Notice I am projecting from the temporary table I just created named table temp. So I'm saying from that table temp, give me the customer number, customer name, rep number, and last name, and put those columns into a temporary table called answer. So I'm joining the two tables together with the join column having to be represented in the where, and I'm storing that result in a temporary table. I'm then using that temporary table to select only those four columns that I ultimately want to see. Normal set operations involve three different types of join. A union includes all rows that are either in table A or in table B or in both. An intersection would include a table containing all rows that are common in both table A and table B. And the difference is rows that are in table A but are not in table B. This is commonly displayed using a Venn diagram. So a union would include everything in both tables. Example 24 uses union. It's on page 63. We're going to list the number and name of those customers who have orders or are represented by sales rep 65 or both. So the first thing that we have to do is join the two tables together. So here's our join. These three lines are our join function. So we're joining these two tables where the customer number from the orders table is equal to the customer number from the customer table. Again, because the field name is the same, I have to specify the table name followed by a dot to separate the table name from the field name. On both sides, it separates these two pieces of data. Once these two tables are joined together, I'm storing that into a temporary table called temp1. The next thing I'm doing is selecting the columns that I want. So I'm using this temporary table I just created, the joined items together, and I'm saying, well, I only want the two columns, customer number and customer name. So the project is giving me the two columns that I want. Once I have those two columns, I'm storing those in a temporary table called temporary 2. The next two lines are the select. So here I'm saying I want you to select out of table customer wherever the representative number equals 65. So a select, remember, is giving me the entire row. So now I'm going back to that original table customer, and if the rep number was 65, there's my criteria, store those rows in temp3. Now I'm pulling only certain columns out of this table that I just created, temp3. And I'm saying, well, out of that table, I only want to see the customer number and the customer name, and store that in temp4. So in reality, these two set commands here are creating one set of records that ultimately ends in temp2. These two commands here are creating another set of records that ends with everything being stored in temp4. And my final step is I'm creating a union right here. And remember what union does. Let me go back to that previous slide. Union is going to include everything out of both tables. So this union command is going to give me everything out of temp2 and everything out of temp4. And it's going to put those rows together and store them in something called answer. Another type of join would be an intersection. An intersection is going to show me only those records that are common to both tables. Remember, the union included everything in A and everything in B, but an intersection is only going to include the part that is common to both A and B. Here's an example of a union on page 63, example 25. We want the number and name of those customers who have orders and are represented by sales rep 65. You can see this starts off very similar to the previous example. I'm joining table orders and table customer, and I'm joining them on the customer number equal to the customer number, and I'm storing that resulting data set in a table called temp1. I'm using that data set to project, which is going to give me only certain columns out of this, the customer number and the customer name, and I'm storing that result in temp2. So these two commands, just like before, kind of go hand in hand, and they end with the creation of this table, temp2. Then I have these two commands. They also go hand in hand, just like before. I'm selecting, remember, the rows out of customer where the rep is 65. I'm storing that in temp3. I'm using that to project only certain columns, the customer number and name, just like the same columns as before, and I'm storing that in temp4. So my two resulting data sets, one is being stored in temp2, the other is being stored in temp4. And so my final action is to intersect temp2 with temp4. Because I'm doing an intersection, I'm only going to see the records that are shared between these two resulting data sets. The difference tells me the records that are in one table but not in another table. So in this case, I would not see the records that were common to both, and of course I would not see the records that were over here in B. I will only see the records that are here in A only. Very similar example. The number and name of those customers who have orders but are not represented by sales 65. So just as before, the first two commands find me everybody who has orders. So I'm joining table orders and table customer into temporary 1 and then pulling only the customer number and customer name and storing that in temporary 2. The next two commands are finding me everybody who is rep 65. I'm selecting the rows from table customer where the representative number is 65, storing that in temp 3, and then pulling only the two columns customer number and customer name and storing it into temp 4. The big difference here is this at the end. I'm using subtract, and I'm saying subtract 4 from 2. This is letting me see everything that's in 2 that is not in 4. Be very careful with the order you put these two table names in. If I reversed these two temporary table names, I would get a different resulting data set. So this is showing me everybody. This is showing me only those who are 65. And I'm saying we'll take everybody who's 65 out of everybody and store that resulting data set in table answer. Thus I'm getting everyone who is not represented by salesman 65. And that concludes the remainder of your lecture for Chapter 2 in CIS 307.